All right, it's exactly 11 o'clock on the third Thursday, so let's get ready to start this seminar. Welcome to Ace Your Science, our monthly webinar by Ace Glass. My name is Dr. Fiona Oxsher. I'm the Southeast Regional Sales Manager, and just like all of my colleagues, I'm a chemist by training. We started the seminar in order to just pick some topics and go in a little bit more depth, or maybe show you some new products that you might not be aware of, and just maybe help improve your process a little bit. So today we're going to talk about pressureware, and I'm going to jump right in it. This is going to be a 15-minute presentation, and then we're going to have a 15-minute question and answer session. If you do have a question throughout my presentation, please go ahead and click the little question mark bubble on the top and just type it in, and I will collect all the questions at the very end and just go through them then, so that we don't completely blow the time window. But I will make sure we get to all of the questions. All right. So pressure glassware. Typically, when I go see my customers, I always ask them questions, just randomly pick their brain and just see what their thoughts are. And so recently, I asked a lot of them, what are your first thoughts when you hear pressure glass? And some of the answers were, well, first of all, categorically, pressure and glass do not mix. We only use stainless steel, right? Or, well, we've thought about it, but we're not really sure of the limitations, so don't know. Or just simply, we've heard of it, but we're not sure of the special coatings you might need. So overall, the consensus is always, I need to know more. So this is where we're going to start and jump right into this webinar. All right, so first let's go a little bit over the theory of glass and what we need to know in order to understand the limitations of the glassware in order to be used with pressure. So typically glass we think of is silicon dioxide, and if it is crystallized in a perfect crystal structure, so a perfect silica dioxide, it's in a tetrahedral crystal structure. That said, most of the glass that we use is borosilica glass, our standard glass, not quartz, which would be the silica dioxide. And so it's not quite as perfectly crystallized. It's kind of more like a random arrangement of the silica dioxide particles. And as a matter of fact, there are always some inclusions, mostly boron, hence the borosilica glass, but it can also sometimes be sodium or potassium oxide or even aluminum oxide. And so typically what happens is you get these inclusions, and then the silica dioxide forms a pocket around it, and overall that just destabilizes the glass a little bit. I don't know if you remember back from inorganic chemistry, if it ever was mentioned, glass is technically a liquid because it is not a perfect crystal. Yes, it does harden, but according to the structure, it is a liquid. And so it's a more fluid system. So we have to kind of wrap our head around what really is possible and what not. So we don't talk about glass today. We're actually going to talk mostly about the amorphous structure of borosilica glass, just simply because that is what most of our standard catalog items are made of. All right, so some of the important variables that we do have to think about is, on one hand, the glass thickness, especially dealing with positive pressure. There's a lot of pressure on the wall, so we need to think about a very thin glass wall is probably not ideal. We probably have to use a more heavy set wall, and most of our pressureware does have that. It's just very important in order to increase the durability for using it with pressure. The other thing is the wall evenness. If you have ever dealt with any of our products or have met with any of my colleagues or with myself, you probably were told that we still hand make all of our glass. It's still hand blown in Vineland, New Jersey. And so a lot of people have questions about the wall evenness. But if you have ever met us at a trade show or an expo, we always have a cut round bottom cylinder with us, so you can see how even the wall thickness is. And it really should have no bumps, no valleys. It should just be very even. A lot of times when you have amateurs blow glass, you get some thin spots and some really big bumps in there. And that, of course, destabilizes the glass as well. So we have really awesome glass blowers, and they are very great in keeping the wall thickness even. So another very important variable is actually the vessel shape. So when we increase pressure, just talking about the wall evenness, every time we have to put a sharp corner into a vessel, that can compromise the wall evenness. So in order to keep it as even as possible, rounded corners are the way to go, so that we can just really keep the glass intact and keep its integrity. The other thing that we do need to think about is the buildup of the pressure. So if you just simply hook one of those pressure vessels up and just charge it very quickly, the glass is probably not going to like that, right? So you should evenly and slowly charge it so that you don't just get a rush of pressure in there. It's very important. And last but not least, the thing we also need to think about is temperature. The reason that is important is because, of course, pressure and temperature are directly related. If you think back to the gas laws, PV equals nRT, right? They do stand in a direct relationship. And so typically with temperature, the pressure is rising as well. So we need to consider that. In typical borosilica glass, you can easily go to ambient conditions or 15 psig. You can always pull a vacuum on it. They're rather sturdy when it comes to vacuum, so you can really evacuate it nicely and then charge it again with a gas like nitrogen or argon, so that is never really a problem. But if you really build it up, and some of you have these pressure reactions where they put reactants in the vessels and then put them in an oven, let it react overnight, and the pressure really rises, that is where the problems can come in. So in order to know how high you can go in a vessel, you will always find this information printed on a pressure rated vessel. And so on one hand, that is the pressure limit. And on the other hand, it will also give you a temperature. All of the vessels we make are rated at 100 degrees Celsius. And again, the reason this is important is because temperature and pressure are in a direct relationship. And the rule of thumb is for every degree Celsius that you go up, you technically should take your pressure down half a psig so that you don't overextend it. You can lose the integrity of the glassware and it eventually can actually explode. So for example, here we have a rating of 35 psig at 100 degrees Celsius. So if we go, let's say, to 110, that would be an extra 10 degrees, half a psig lowered for each degree. So we would have to lower it by 5 psig, and now our rating would only be 30 psig instead of 35. So that is very important to know. What is also very important to look out for is the joints that you are actually using to connect your glassware pieces. A typical reactor head, for example, or a typical round bottom, they mostly have standard taper joints like you can see here. But of course, when you charge that up and the pressure increases, those will just simply pop out. You can put a keg clamp on it, but even that plastic will eventually go. So the way to go really here is to use a ace thread, where you have a threading in the glass and you use a Teflon plug with a front sealing O-ring. And therefore you can charge it without losing or just shooting out random peripherals. So that is very important. What is also important typically is to make sure that you have a pressure manifold if you operate under pressure, especially if you use a reactor. And with that pressure manifold, you would see a pressure scale, and you would also have a rupture disc in it, which is important because that can help keep you safe. Sometimes errors happen and a gas wasn't shut off or something happens, a reaction goes wrong. And instead of now at 35 psig, you are all of a sudden at 45 or even at 50, which can really compromise the glassware. So if you have a rupture disk, it will just simply pop and your pressure will be released. And therefore, you keep your glassware safe and probably yourself safe because you don't have glass flying all around. And the pressure gauge is just simply a simple way of making sure you know what the pressure in your system is. All right. And then what happened here? One is missing. Okay. We have different types of pressure vessels. So there it is. As you can see, they all have round or have rounded corners, and they all have the ace threads. So you can go anywhere from a round bottom flask to a pressure tube or a bottle or even a reactor. We can even make those jacketed. So, but all of that would have to be made with heavy walled glass and with the rounded corners. And then, of course, every single piece is tested individually to really give it that pressure rating. We also do have some accessories. As already mentioned, temperature and pressure are directly related, so it would be a great idea to actually know the temperature of our system. So here we just simply have a thermal well going in where you can pop a thermometer in and know your reaction temperature without actually releasing the pressure or having to somehow fiddle something in there that is not designed to be that way. This will keep your system stable and you can still have a pretty adequate temperature readout. We also have pressure gauges that you can add so that you can read out while your reaction is going. There are sampling ports. Well, this is a pouring spout, just because now all of the glassware has these ridges from the ace threads. Sometimes it can be tricky to actually pour it out. So you can just screw on a spout and have a clean pour rather than having residues in all of the threading. And then here we have a sampling port. Now you cannot sample while you're operating under pressure. You actually have to release the pressure and then you can sample. There's no way you're gonna get a syringe in there or somehow pull a sample while the pressure is on. But you can briefly interrupt your reaction, sample, and then go right back to it. We also can operate some larger vessels. In this case, we have 2 pressure reactors here. This one is a standard jacketed pressure reactor. Unfortunately, I didn't pick very well because I picked 2 two-piece reactors. We also have a 1-piece reactor. Personally, I find it a little bit more cumbersome because you can't open it to clean it out very well, which is very possible with the 2-piece reactors where you have a body and a head. That said, the 1-piece reactor is rated at 45 psig, where the 2-piece are only rated at 35 psig, which can make a big difference. As you can see, all of the peripherals are screwed in, whether it is your addition port. Of course, here you would need a pressure equalizer, or here a condenser. Everything is screwed in. In this case, we have a flex shaft. If you might not have that much room in your hood, that's not that big of a deal. We can help you with that. Over here, again, we have a pressure manifold and all screwed in peripherals. We have an overhead stirrer. They are just pretty easy to handle. I feel like I much prefer those and typically recommend those to my customers. But also, again, a 2-piece, we have a head and a body. And then down here, we actually have a filter disc that can be screwed in. So this would be a full filter reactor. So if you have a reaction going on and you have a precipitation, you don't even need to pour something or somehow handle it weirdly. You can just simply open the spout on the bottom and empty it out. And since it's charged under pressure, this will probably happen pretty quickly. And of course, one of my customers once asked, you have a powder funnel here. Of course, you can't charge it up to a higher pressure while the powder funnel is still on there. If you try to add any kind of solid, it's going to blow up in the air. So that is just to easily and conveniently fill the reactor. This is not to be used under pressure. All right, then another pretty important thing is coatings. One of the biggest dangers in using pressure glassware is if you have a chip in it or a crack, a little star fracture, the moment you put pressure on it and the glassware is already compromised, that can really be a big problem, and that glassware can just simply explode. So one of the biggest things we noticed is that while cleaning, maybe you just very slightly hit the edge of the sink, or you get a light scratch in it. So because of that, since that can really compromise the glass, we typically recommend an epoxy coating on the glassware, and this would be the sign that you would see on it then. And that is just simply literally an outside coating of your pressure vessel that would kind of be almost like a scratch protection, just so that you kind of are prepared to avoid these little cracks, scratches, anything that can eventually give under pressure. I know it seems like very common sense, but I do want to point this out because I recently somebody had has been doing this and had called me up and said, hey, there's a problem with my pressure tube. Diamond cutters are not a great idea on pressure glassware. If you want to mark something, please use a Sharpie. Do not take a diamond cutter and make a mark on it, not even on the epoxy coating, because that will cut through the coating and it will compromise the glass. And this is going to be the very position where it goes. And where you then have breakage or even an explosion, and the hazard for that is simply too big. So we want to try to avoid that. All right. We do have some literature about this topic because, of course, there's always more to say. It is on our website. If you want to go to aceglass.com/literature, you can find this. On one hand, it will show you our standard catalog items, but also it always has educational sections in it, just if you want to follow up and read up on some of these things. Or you can send me an email at f_oxsher@aceglass.com. Or you can contact your local sales rep. If you're familiar who he or she is, please reach out to them with any questions. We're always happy to help. Or you can just directly call our office in Vineland. If you don't see what you're looking for, we can always custom make your product. So just send us a sketch. Our glass blowers are really awesome. I don't know if I already stretched this enough in the beginning. So they will do their best to actually help you get exactly what you need for your setup. Here, just for reference, is just a quick map with our territories, where you can look up your respective sales rep. This is also on our website. So you can look up our contact info, phone number, email, or just simply who we even are, who should be working with you. And last but not least, follow us on social media just to stay up to date for new products or for our next webinars. This webinar was recorded and we will actually put it on our YouTube channel, so you can revisit it if you want to in the future. But also I want to invite you for our next ACR Science webinar, which will be, as always, on the third Thursday of the month at 11 o'clock Eastern time. And in this case, it would be July 17th. My colleague from New Jersey, Kathy Batista, is going to talk about different flanges and where they are adequately used, or what you should think about in order to use a proper flange for your setup. All right, with that, I do want to thank you for joining our webinar. I appreciated your attention, and I love that you're all coming here. As I said, if you have any questions, please feel free to reach out to me by email or phone, or just reach our office directly. And with this, we're gonna go to the questions now. Let me just see if I can easily get back into my program here so I can actually see your questions. Okay, so do you pressure check every piece of glassware, and what is the upper pressure you test to? So we do indeed test every piece of glassware, just simply because this is a very delicate matter, and we cannot put a seal on it. Hey, yes, it is tested to 35, 40, 100, whatever it is, PSIG, without actually really knowing that, yes, this piece is flawless and can go to that. Some of our pieces, like I have been talking a lot about the 35 and the 45 and the reactors, but as a matter of fact, we actually have tubes that can go up to 150 psig. So if you have any kind of limits that you want to go to, just contact your sales rep and let us know what you're looking for, and we for sure can make sure that you get an adequate piece. We can also custom make pieces, not very big reactors. I know we're typically known for making 20, 50, 100, 200 liter reactors. For that, we do not have the equipment. But anything that is bench scale, we can actually test, even if it is a custom piece. So that would not be a problem. Do you have flow-through pressure columns for performing high-pressure dynamic testing? What is the highest pressure your threaded glass can withstand? So the highest pressure, like I just said, that we test for right now is 150 psig. We do not have a flow-through column as a catalog item right now, but like I said, we can always make custom pieces. So this would be worth contacting your rep. I am not sure where you are located, but I can later just go back to that little map and you can just have a look, or maybe you already looked or know your Ace Glass rep. Give them an idea, give them a sketch, and we can see what we can do for you for sure. Can you comment on the advantages and disadvantages of threads with O-rings versus ball and socket joints with clamps? I most certainly can do that. So ball and socket joints, even if you have clamps, it is just like with the standard taper joints, they are more prone to just simply pop up. Those clamps, they will hold so long, but then again, most of those clamps are metal, and if you put a lot of pressure on, you actually then also put pressure points right on the edges, and you can scratch your glassware with that, and you can compromise it in turn. The threads, especially with the front-facing O-rings, they have great seals. So we don't really have to think about how tight do I need to make it? Is it really perfectly fit? They are just, especially for pressure glassware, perfectly made to make sure if you just hand tighten them, the seal is perfect, and they're in so deep with so many threads that no matter the pressure, they don't just pop off. So they will easily go to the 150 psig, and you won't have any issues with that. So I have personally tried to put ball and socket joints under pressure, and I mean, maybe I'm a little bit of a klutz sometimes, that's possible, but I think all of us have those days. And I have actually managed to blow a condenser off. So I would 100% recommend the Ace threads with the front-facing O-rings. And I'm saying the front-facing over the back-facing simply because you get a much better seal with those. All right, what else do we have here? Are all of the pressure catalog items handmade? Yes. So at Ace Glass, we don't really pour anything. We don't really machine anything. We really have awesome glass blowers that are trained at a local community college and then come to us through apprenticeships. They are awesome. Really, there's very rarely something where they say they can't do it. And even everything that is in our catalog is still handmade. So, and we pride ourselves with that. There's just a difference than having a seam somewhere because the glass was poured, and then you never know how it actually comes out. Yeah, what is the highest pressure you can go to? So just to reemphasize, the highest pressure we go to at the moment are with our tubes. That's at 150 psig at 100 degrees Celsius. So we then have to consider up and down, depending on our temperature. Again, rule of thumb, half a psig per degree Celsius temperature change. So just keep that in mind. But overall, that is what we recommend and what we know is safe. Of course, you know, we always have people that go a couple psig over, a couple degrees over, but this is where we know we can operate safely. Do you sell rupture discs separately? Well, yes, we will have to, because if you have a pressure manifold and something happens and that rupture disc actually pops, you need a replacement. But not just that, you might also want to use your manifold on one hand, maybe with a tube that goes, to 120 or even 150 psig, but then, you have a new setup and you have a reactor that only goes to 35 psig. You should still be able to use that same manifold. So yes, you can absolutely get the manifolds separately and according to whatever pressure rating you need there at the moment, so that you don't have to have 75 separate rupture discs sitting there. And also they are super easy to install. I tried to show that little sketch and probably forgot to point that out, how easy it is, but you seriously just pop them in and screw it on. It's super easy. You don't need a glass blower for it. They are not sealed in there. They can just very easily be exchanged. Also makes the cleaning of the manifold very easy, so that is not that big of a deal. Do we make custom quartz pressure wear? So that is another one, I guess. I briefly touched on quartz on the very first slide. So if you remember, I said quartz has a tetrahedral crystal structure, and in and of itself is much more organized than the borosilica glass, which has kind of an amorphous crystal structure. So that alone already gives it a much higher capability of actually taking pressure and dealing with it. So quartz vessels are much differently rated than regular borosilica glass. I've never had the request for a custom quartz pressure vessel, but I am sure we could come up with something, and you would still get, the testing and the certificate to make sure it is what you need and what you need for your, paperwork. If you have certain standard operating procedures that need to be kept, so that would not at all be an issue, I would think. All right. Do we have any other questions? Don't think so. So as I mentioned, let me just go back. Here is the map again, where you can see your sales rep again. And as I mentioned, if you have any questions, reach out to any of us. We're all chemists. We've all been in the lab, been there, done that, and have made our own experiences, and maybe can give you some input of what worked for us or what didn't. And we can help you, exactly get you what you need for your process. So that should not be an issue. And with that, I really want to thank you for attending. And we're already looking forward to seeing you on Thursday, July 17th with Kathy Batista. Have a great afternoon.